In these particular exponential equations, you will notice that they do not have a common base. So when you are solving an exponential equation without a common base, your strategy is going to be to write it in logarithmic form. So starting with this first one, I'm going to spell the word log as log, since I don't see the number e being used. Remember that starting with your base of 8, that is your subscript. The power goes on the side by itself. And then whatever it's equal to, that's what you're actually taking the log of. So in this case, we have the log base 8 of 1,165 is equal to negative x plus 3. Now we will get x by itself, so I will add 3 to both sides. You cannot add the 3 to the 1,165 because you are taking the log base 8 of that number. So you're just adding the 3 to that whole log. And then that's equal to negative x. And then my final step there is to divide both sides by negative 1. And then we get on our calculator to punch it out. Now you'll notice when I punch this out using the Desmos Scientific Calculator, because it does not have a key that will allow you to do just any base, I had to do the change of base formula right here. So that's how you would type that in with the change of base formula. And we're rounding our answer to 2 decimal places. So notice the 5 will tell me to round the 9 up, and when I round that up, that of course rounds the 3. So my final answer in this case is going to be a negative 6.40. Okay, so on the next problem, again, you'll notice that there is not a common base on both sides. So again, we will write it in logarithmic form. And because I see an e being used, I'm going to spell logarithm as ln. All right, so we'll start with the base of e here. That's understood to be the base of this logarithm, but you can show it if you want. The power of 4x plus 11 will go over here. And then the answer of 16 to the power of 2x plus 12 is what we're taking the log of. Now, if you remember properties of logarithms, there's a property that says if you're taking the log of something raised to a power, you can actually pull the power to the front. So I'm going to pull down the 2x plus 12. It's multiplied by the natural log of 16. I'm not going to show that base of e anymore. It's understood to be there. And then that is equal to 4x plus 11. Okay, so if I go ahead and multiply both sides here by the natural log of 16, I get a 2x times the natural log of 16, plus I have a 12 times the natural log of 16, and that is equal to a 4x plus 11. Now, anytime we are solving for a variable, we need to get all terms with the variable on the same side. So I basically have an x here and I have an x there. I'm going to put them on the same side, so I'll go ahead and subtract the 4x. So that gives me a 2x times the natural log of 16 minus a 4x plus my 12 natural log of 16 equals 11. And then since this term does not have an x, I need to move it to the other side, and I do so by subtracting it. So at this particular point, We have our 2x times the natural log of 16 minus the 4x. And then we have an 11 minus a 12 times the natural log of 16. Okay, so again, we're trying to get x by itself. At this point, since both terms have an x, we'll go ahead and factor it out. Put all of our leftovers in parentheses. So 2 times the natural log of 16 minus a 4. And that's equal to 11 minus 12 times the natural log of 16. And then my final step here will be to divide by the 2 times the natural log of 16 minus 4 on both sides. And so they're going to ask for your answer to be first written as an exact expression. That's what this would be. And then they want a decimal with 2 places. So as you can see, once I punch this out on my Desmos scientific calculator, when I round to 2 decimal places, my value of x is going to equal to a negative 14.41. So that would be the second part of the answer. Okay, on this last one, what I wanted to point out is, once again, both sides do not have a common base, but before you put it in logarithmic form, you need to have the exponential term by itself. So you would first divide both sides by 3, so that I have e to the power of x plus 3, and that is equal to 119 over 3. And unfortunately, that does not simplify, so just leave it as the fraction. So now we're ready to put it in log form. And again, since the base e is being used, I'll have to spell it as ln. It's understood to be a base e, but you can show it there if you want. My power goes over here by itself, and then the 119 divided by 3 would go here. So now we are trying to get x by itself, so we will subtract 3 on both sides. So I have the natural log of 119 over 3 minus 3 is equal to x. So I punched it into my Desmos calculator, and when I round it to 2 decimal places, x is going to equal to a 0.68.